Welcome to 1.1 Functions, Domain, and Range, Part 2 of 3. In this video, we'll be talking about the vertical line test and how we can use it to determine if a relation is a function. And then we'll be going over the concepts of domain and range for data sets. So the vertical line test, this is a way of determining if a relation is a function when viewing its graph. If a vertical line could be drawn at any point and only intersect the relation at one point, then the relation is a function. Okay, so let's do this for some of the examples that are shown here below. So we are given a linear curve or linear function, and we want to apply the vertical line test. So what we can do is we could just draw a simple vertical line. Okay, and I'm drawing it off to the side because I'm going to animate this and allow it to move. Okay, so if I grab this vertical line and then I move it along the curve, okay, I can see that it always intersects the graph only at one point as I move across. Okay, so the fact that it intersects only at one point tells me that each x value has only one y value. So that means that yes, this is a function. Okay, so I will answer that below. I will say the vertical line only intersects at one point. Therefore, it is a function. Okay, and in other words, what this is saying is that each x corresponds to only one y value. All right, let's go ahead and apply this vertical line test to the next one. I'm just going to go here and grab my vertical line. So as I scan this across, you can do this with your pen or pencil and just run it along the graph. And you can see, yes, it always intersects at 2 points on the curve. Okay, the only time it only intersects once would be right at that vertex, right at 1. But anyway, along here, we can see it always intersects at 2 points. So this is not a function. Okay. So we can say the vertical line intersects at 2 different points as it moves through the graph. Okay, so we can just say, therefore, this is not a function. Okay, and we will go ahead and apply it again to this one here. Let's just grab this here carefully. All right. Okay, so this next one here, we have a circle. And as the vertical line passes through, yeah, we can see it definitely fails at 2 different points, so not a function. Okay, I'm actually going to copy my same answer from before. Okay, the vertical line intersects at 2 different points as it moves through the graph, so therefore that is not a function. Okay, just to elaborate a little bit, we could say each x value has more than one y value. Okay, so that breaks the rule for a function. Okay, and our last one here. Let's just grab this one more time. And we have a parabola that's opening down, and it looks like it's always just intersecting at one point. Okay, so we can say, yes, this is a function. So the vertical line always intersects only once. Therefore, it is a function. Okay. So in fact, you probably noticed a pattern with the parabolas that open up and down. They will always pass the vertical line test. That means they will always be functions. Okay. Also looking at the linear line here, linear lines will also always be functions. There's only one case where it won't be, and that would be if you had a vertical line. Okay, if you had a vertical line on the graph, then yes, that would definitely fail the vertical line test. Okay, now moving on to domain and range. So the domain is the set of first coordinates of the ordered pairs in a relation. Okay, so the domain for a relation, it's always just a collection. That's another word that we use for set, is collection. So I'll just highlight that. Okay, set just means collection. So the domain is the collection of all the x values for the relation. Okay, so there can be many values for x, depending on what this relation looks like. So the domain is a collection for all of them. The range is very similar to the domain, except that it has to do with the y values. Okay, so this time it's the y values. It's the whole set or collection of them. Okay, we'll kind of color code this. So the red for domain and the blue for range. Okay, so let's do a couple examples of this. So in this lesson, in this video today, we're only going to be looking at data sets, finding the domain and range for data sets. And the next video, we'll do it when we're looking at graphs or equations. Okay, so in this example here, it says determine the domain and range of each relation. Use the domain and range to determine if the relation is a function. So I guess we can do this not by just doing a vertical line test, but by also looking at the domain and range. So here is our data set. We just got 5 ordered pairs in there. Okay, the brace brackets again are used to denote the set. So they're the nice curly brackets. So brace brackets, it just means the set, okay, or the collection. So we have that set of 5 points. I want to write out the domain. So the domain, I kind of draw that curly bracket, and then I'm just going to list all the x values in ascending order. Okay, it's very important that we follow that. So we're going from smallest to largest. So we'll do -3, then -2, and then we got 5 twice. So we only write it in once. We don't want to repeat the elements that are in the domain. So we only write it once. And then 6 is our last one. So that is the domain. The range, this is all my y values. Okay, so I'm going to be looking at the y values now. Okay, we're going to write them in ascending order also. So we'll go with the smallest one, looks like -8. Then we have -6. So that's those two. And then we got, we could do 3 and then 4 and then 7. So 3, 4, 7. Okay. All right, notice the range has one more element in it than the domain. Okay, so when I say the word element, I'm just referring to the items that are in here or the numbers. So there's 4 in the domain and there's 5 in the range. What that means is one of these elements here, which we know is the 5 points to -6, and it also applies to the 3. So 5 has 2 outputs. So in terms of function, this means it breaks the rule. So we can say here, this is not a function because the x value 5 corresponds to 2 y values. What was it? -6 and 3. Okay, so each x can only have one y. So this is breaking that rule because 5 corresponds to -6 and 3. What that would look like on the graph is we would have -5 somewhere out over here, and then we would have the 2 y values. We'd have one at +3 and another one down at -6. Okay, and they're right on top of each other, and that would actually break the vertical line test, right? Okay, part B. Now we're going to look at a nice table, and we'll do the domain and range. So the domain is always all the x values, so I'm going to grab all these here, and I'm just going to write them in the domain, and I'm also going to put them in the proper order. So they already are in the right order, going up from 4 to 10, so I'm just going to write those in. Okay, looks like I got 7 elements in here. Okay, and now for the range. These have to go in ascending order, so we're going to go start with the smallest 5. So go 5, 8, 9. And then we got 11, 12, 14, 22. Okay, we also have 7 elements in here too. Each one is pointing to its own. So we can see here in the table, none of them are repeating. So this is a function. So we can say there are 7 elements in both the domain and the range. Therefore, this is a function. Usually what happens when your relation is not a function, you're going to have not the same, you're going to have a smaller amount of elements in the domain than you do the range, because that just means that some of these would be pointing to more than one. Okay, we have the exact same amount in both, therefore this will be a function. Okay. All right, so yeah, there you have it. We now know how to find domain and range. And we also know how to perform the vertical line test. Okay, I hope this has been helpful. Just remember to go into Teams to answer um, the ALL question. It's actually just going to be the second one right here. Okay, you'll be able to see that in Teams, and then this will be our homework. Okay, hopefully this has been helpful. I will see you next time.